Today we're going to see about introduction of ATMega controller, something that is AVR controller, that is an advanced virtual RISC, and it is a tiny computer on a single chip. It is said to be a control devices, and the architecture attributes of a system that is visible to the programmer, and these attributes have a direct impact on a logical execution of a program. It has an instruction set and a number of bits used for data representation and I/O mechanism and addressing techniques. The design issues whether a computer will have a specific instruction, whether it will let us see the processor organization and architecture. So AVR is produced by Atmel Corporation. So it is also an reduced instruction set processor. It has different features compared with the other like sleep modes 6, and it has an ADC, an internal oscillator, and a serial data bus, and it performs the instruction in a single execution unit. And these microcontrollers are very fast, and they utilize low power. They utilize low power to work different power saving modes. There are different configuration of AVR microcontrollers. It has some hardware details that are transparent to be a programmer and a control signal interface and memory technology. And many computer manufacturers offer a family of computer modules and have a same architecture and difference in organization. So here all Intel family have same basic architecture. So the architecture may survive many years, but its organization change depends with the changing in technology. So these are the different groups of AVRs. That is classic AVR, mega, tiny, and special purpose AVR. It is mainly used for gaming operations. Let's get familiar with AVR parts. So AT is something that Atmel, mega is something that group, and 128K is the flash memory. These are the few processor in AVR. And next is your pin diagram of AVR. So the microcontroller support to signal except 5 pins. So here there are 40 pins, and let us see in detail. So here VCC and ground for supply of voltage, and XTAL1 and XTAL2 is that is for clock generation. It produces a clock frequency up to 16 MHz. Next is your reset pin, a low level on this pin for no longer 1.5 microseconds length will generate a reset. And AVCC, the supply voltage pin from ADC should be externally, and A reference, the analog reference pin for the ADC. And this is the ATMega 32 pin out and descriptions. And this is port A, where it has a 4 ports, that is port A, B, and C and D. So port A is PA0 to A7. It is an 8-bit bidirectional digital input output port. So it is programmed to serve an alternate function as analog input for ADC, whereas your port B is PP0 to PP7. It serves an 8-bit bidirectional digital input and optional internal pull-ups, and port B pins are tri-state when reset. And port C is PC0 to PC7, serves an 8-bit bidirectional digital input output port with optional internal pull-ups, whereas port D serves as an 8-bit bidirectional digital input output port with optional internal pull-ups, and port D pins are tri-stated when resetted. So this is a general programmer view of port A, B, C, and D. And each port has an 8-bit register, that is data direction register, and port input pins register. So here defining a pin either as an input or output. So this in this block, each bit of DDR determines the direction of corresponding bit in port X. Next is in this case to make a pin to go high or low. So here the data register stores data to be sent corresponding pins of the input output, and the data register for the port X. Next is the basic architecture of your AVR. Let us see this architecture in detail in next class. Thank you.